Well, this is part 2 of that video. It turns out that there were a couple typos in the previous video that I'd like to correct. I probably should have just hit this run button and note that there are a couple things here to fix. So in this line here, there was a missing parenthesis. In this line here, note that there is no polynomial p to deal with. But we can refer to the current polynomial as this. So from the perspective of a particular class, the key word "this" is referring to this particular object itself, and so it's kind of like saying me, and so this is a non-static method. So we are referring to the polynomial this. In fact, all the variables that I have here, including like this a, I could have prefixed it with this dot a dot length. That is still reasonable. Note that I'm not going to do that. If I run this again, okay, so now I have a different error. This is back in this add function. Again, P. So this is something that we did in class on Tuesday in lab. Went over this. Turns out that P2 is a polynomial. That polynomial doesn't have a length, but it's a variable does have a length. So we should be able to do that. Run that. I'm able to get a graph when doing that, and so I'm able to demonstrate that looks reasonable. The other thing to do is to just kind of go down here and say, what is the output of this? We haven't done everything here, so I think it's worthwhile for us to just continue on with our coding, and then get to a point where we can test this out and look at everything. All right. So let's go back up here to this multiply function. Now, if you look at the lab page in particular, you'll see that what we really want to do is define a new polynomial where we have a certain length, and so the number of coefficients that we need for this polynomial is going to be very similar to what we did in negate. So I'm going to just copy this code from negate and put this in here. So again, the keyword "this" is just referring to this particular polynomial. And rather than multiplying everything by the negation, I'm just going to multiply every element in this Q polynomial by this variable b. So here, I'm just multiplying the 8th term by b, this parameter that's coming in. So here, this is a sort of multiplication of the variable b by, or multiplying the polynomial, this polynomial, by b, and returning a new polynomial. So polynomial q, that's my new polynomial. I'm creating it based on this current polynomial. For every one of the coefficients of my polynomial, I'm going to multiply that by b. Okay, that's going to be this multiplication. So adding two polynomials, this is something that we did last time. So let me just widen this so that we can see all the code here. So let's kind of refresh what we did here. So we have two polynomials, P1 and P2. We want to create a new polynomial Q, that's the sum of those two. So Q of x is equal to P1 of x plus P2 of x. Here we had to worry about the degrees. So P1 and P2 have possibly different degrees. Let's say this has degree n, this has degree m. And then we want to be able to make sure that we're doing these correctly. So if polynomial P1 degree is greater than P2 degree, then we're going to do the code that we have here. We create a new polynomial Q that has the same degree as the larger of the two degrees. In this case, that's P1. And then for every one of those entries in the smaller one, we are, or excuse me, in the, for every place that we have the coefficient in the smaller degree polynomial, I just want to add that coefficient to this Q polynomial. So Q is going to contain a copy of P1, and so what I'm doing in this case is just adding to that to get that resulting polynomial. So I can do the same kind of business down here. I can then allocate that polynomial, and here, since P2 is the larger of these, I want to loop over all the elements in the smaller of those two and add from that particular one. So here, I'll just get rid of these. So here, P1 is the plate for every one of these coefficients here. That coefficient is, that power of x is in both P2 and P1. So at the end of that, whichever one of these Qs I used, whether it was this one or whether it was this one, that's the Q that I'm going to return. Again, I don't want to have polynomial Q inside of here and then polynomial Q here. I have to define that Q outside of this, because if I don't, then that Q is only valid inside the curly braces here. And so if that Q is only valid inside these curlies, I'm going to get something where I'm not, this Q variable is undefined. All right, so that's the add. Now, multiply, I said this is going to be the hardest. We'll see. It's not. Okay, so we just have to think a little bit about this. So note that if I have a degree m polynomial times a degree m polynomial, that this is going to be Q, let's say P1 has degree m, P2 has degree n, then Q is going to have degree m plus n. So if I have, for example, a linear times a linear, I'm going to get a quadratic. If I have a quadratic times a linear, I'm going to get a cubic. And so what I need to do in these cases is allocate enough space so that I have that many things. So let's try and do kind of something like what we're going to do up here for add. Well, maybe we didn't even do that, but let's do this in a way where we allocate an array first. So I'll just have double A is assigned. So double A is an array. It's a new double that contains the right number of elements for a degree m plus n polynomial. So one of the things that we said earlier in the previous video was that if I have a degree n polynomial, for example, a quadratic, it has three terms: the x squared term, the x term, and the constant term. So in general, I'm going to have one more entry in this array of coefficients than the degree of the polynomial. So this is going to be degree m plus n. Now I need to be a little bit careful here that if I have the 0 degree polynomial, p of x, I'm essentially multiplying everything by 0. So we need to be careful about the 0 degree polynomial. Well, let's not worry too much about that, at least at this point. And so what are we going to do here? Well, we've allocated space. Now we need to fill in the value for each one of these coefficients. Well, how am I going to do that? Well, for each one of those coefficients, for int I is assigned 0, I is less than Well, it's the degree of that. So that's A, or each one of those entries, I dot length. Well, I need to determine what A sub I is. Well, let's initially start it out at 0. So when I think about the ith coefficient of this new polynomial, this multiplied polynomial, what I really need to do is look at, so if you look back at the notes page, the ith coefficient of this new polynomial is generated from all the cross multiplications that we do of a power. For example, I might have x to the 0 times x to the I, and then x to the 1 times x to the I minus 1, and so on. So I have a summation here that needs to take place. So I'll just have another loop that will do that. Int j is assigned 0, j is less than I, j plus plus. Now, what I'm doing here is I'd like to be able to take the ith entry of one polynomial and multiply it by the jth entry of the other polynomial. Okay, so so we need to be a little bit careful here. I'd like to be able to say something like this: plus equals. Now I want to look at something from P1 plus something from P2. Well, times P1 dot A, some coefficient there, times P2, some coefficient there. Now it's the question of which one of these entries am I going to fill in? How am I going to fill in each one of these particular entries that I have? So, for example, if I look at which when I is 0, that's the constant term. That's just going to be the two constant terms multiplied together. So that's going to be P1 dot A sub 0, P2 dot A sub 0. That's going to give me the constant term. Maybe let's just take this offline here. Well, I don't know, in some comments here for now, where we think about what's happening for each one of these entries. So, like I said, I want A sub 0 to be equal to this business here. Now, what about A sub 1? A sub 1 I can get in a couple different ways. That is, this is the power of x. So it's either going to be P1's constant term times P1's x term, or it could be P1's x term times P2's constant term. Note that I have, for this one, I have one thing that I'm doing. For this one, I have two things that I'm doing. All right, now let's keep on cruising. So for this one, which is the next one, I'm going to have something like this. It's the 0 plus the second, the 0 plus the, or how about the first, and then the first, and then plus the second and the 0th. Okay, so if I look at this, really the indices that I have here, the 0 and the 0, this value and this value add up to 0. In this line here, 0 plus 1 as well as 1 plus 0 both equal 1. And then in this line, 0 plus 2, 1 plus 1, 2 plus 0, all equal 2. So when I'm in this loop here, really what I'm looking at is summing up all of these terms here. So I want to add up this term and this term and this term, and I want to do that down here. So I start a sub I at 0, and then I'm doing this. So this is really going to be something like this. This is going to be j. Now j is going to start out at 0, and this is going to go up to, this is going to look something like I minus j. So when j starts out at 0, this is going to be some value. So j is going to be 0, so I minus j is just going to be I. So when this is the 0 term, well, let's see, we need to be a little bit careful. Maybe this should be j is less than or equal to I. So here, when I is 0, we need to start out at 0, we need to end up at 0. We want to make sure that we have enough values that are in there. Now what? We need to be a little bit careful about what's happening here, because these polynomials may not actually have a particular value where m plus n is going to be actually this should be m plus n plus 1. That's what we're talking about, having one more entry in this array. So note that when this is m plus n, I may not actually have some value here and some value here that add up to m plus n. So we need to be able to figure out how to deal with that and only deal with these particular values when when these entries are valid. So I may not have an m plus n in general for that I value. Okay, well, 15 minutes are up, and so I'm going to stop the video at this point, and we'll pick back up here in just a moment.